Hello everyone. Welcome to the YouTube video of our team named Veritas. Right here, I will be presenting you what is our idea. Right, and I'll be going through our technical pipeline, and I'll also be showing you the website that we have created and the basic version of the pipeline that we have implemented in Google Colab. Okay, starting with our technical approach. Right, firstly, our problem statement was 1701, which was creating a legal research engine, right? So how did we approach on creating a legal research engine? Was that firstly, the main issue is that people do not want to firstly write and explain to the chatbot or to the research system about their particular case, right? So you can just put in the information, right? And we have created a prompt refiner. What the prompt refiner will do is that it will consider all your information, it will structure the prompt, and then that prompt will be passed on to the LLM instead of your prompt being the one that is passed, right? So this significantly boosts performance of a normal LLM output, right? So we have created a large language model based solution, what you might have guessed till now, right? Going further, we have also used the planner, right? What now, the refined prompt which is being passed on to the LLM, right? Because we are using a multi-agent framework. What is a multi-agent framework? A multi-agent framework is a framework where we are not relying on one single model, but we are using multiple different models for multiple different jobs, right? So they work together in sync to create a more optimized and better analyzed solution, right? So one crucial thing which is lacking in most multi-agent framework is the essence of context, right? So most multi-agent frameworks do not have the idea of what the other agent in the framework is thinking, and so both the agents may be thinking differently, right? So towards the initial stages only, we passed the prompt and we created a plan, right? A plan is basically the approach that we will use to solve the problem that the user has given us, right? So we are using a state of the art reasoning LLM, which is O1 mini for here, right? Now what we do is that the main issue with current LLMs, right? Why can't we use chat GPT for legal research works? Is that current LLMs often lack in the information that they have about a particular legal case, right? So what we have done is we have created two separate ways of extracting information, right? Firstly, we have created a legal database, right? Now if I go to the next slide, you will see that the legal database consists of documents like constitutions, acts and bills, local law documents, NCLT and NCLAT, law tribunal, legal books, case judgments, and all the other local legal files that are related, right? So it is an extensive database of all the commercial and till an extent even non-commercial legal data that could be applied to a particular place, right? For this context, we have created a legal database that broadly applies to India, right? And after that, we are also using Google search. Why is Google search important? Because suppose there is a new update in the law, or suppose there is a new law that is being passed, or suppose there is a new news on the particular case that you are searching for, right? Those information won't be available in the legal database that we had already created a while back, right? So these are live updates that need to be recorded, and Google search consists an enormous corpus of data, right? Google has that. Even if we create an extensive legal database, it Google will still have some information which is not present there, right? Even some developments on the case, for example, say Adani and SEBI, the thing which Hindenburg had brought it up, that wouldn't be available in any database that was previously created, and would only be available on Google search. So we are using Google search to retrieve information. We have created a database. We are using state of the art RAG based methods to retrieve that information. I'll explain to you the details of this a little later. Okay, going on to that, now the because this is a legal case, right? So the amount of information involved is huge, right? And most of the times LLMs get confused when the amount of information increases. So LLMs will perform great when there are 5 pages or 10 pages of data, right? but legal files exceed 100, 200, sometimes even thousands of pages of data when it is applying to large companies or large commercial cases, right? So for that we are using something called as context caching. What context caching does is that it caches or it stores the uh, broken parts of a particular uh, corpus of data, and it references it instead of directly it references it part by part instead of directly referencing it together. So this reduces costs, increases efficiency, and even increases the performance of the LLM model, right? Now one problem which comes to the ethical concerns, to the sensitivity of the response, to the appropriateness of the response, and to whether the LLM is doing some malpractice behavior on its own, right? So for that we have created a separate red teaming pipeline, right? Moving on to the tech stack, I'll explain it very quickly. Our tech stack is basically Next.js in the front end, Next.js or Django, Next.js or Flask, or maybe even Django. We have not decided upon that yet. Currently we are using Flask for the backend. We are using Python for implementing our search script, our ML scripts, our RAG scripts, right? We are using AWS for our backend hosting and GitHub Pages for our front end part hosting. We are using Google as a search engine to implement the search query part, and we are using API providers like Grok, Deep Infra, OpenAI, and Google Gemini for using these large language models, right? Quickly coming to our user flow, how will the user flow look like, right? What would it look like to the user, or what would happen in the backend, right? Just a very simple explanation. I'll move to the detailed technical pipeline after this, right? The user flow, user will give an input, right? That would be on the website front end, that would give a request to the back end of the website, right? It would give a request over here, that this would go as an input prompt to the pipeline, right? Pipeline is basically the multi-agent framework I was talking about. Now this input prompt will now go to the planner. The planner will create a plan. The plan will now go to a searcher which will search information about it from the internet. It would also go to a RAG based system. RAG is retrieval augmented generation, which will retrieve information from the legal information database relating to what we have asked, right? And then this retrieved information will be passed to the final information corpus, right? This combined with the input that we were given, combined with the refined prompt, and combined with the plan, we have a final new corpus of information, right? This will go into the final LLM responsible for answering, right? This LLM will generate a response, and that we will consider as our first response, right? Now the issue is that LLMs often hallucinate or create information. LLMs often write insensitive information. LLMs often have inherent biases. LLMs often you do malice or malpractice behavior, or LLMs often also give inappropriate responses, right? And in legal cases it is very important for us to filter that out. So we have also used a red teaming pipeline, right? A red teaming pipeline is basically what takes the raw output from the LLM and checks it for hallucination or information generation, random information generation. It checks it for safety or sensitivity or inappropriate responses. It also checks it for biasness, right? Biasness means that a model may be favoring towards one party over the other just because of trends in its training data, which might not, it in actuality it might not be that one party is better, but model will still favor it because of biases in its trading data. So to prevent that, we are using layered structure, right, where it is checking for hallucination using citations and using confidence values, where it is checking for safety, where it is checking for biases, and then it is suggesting corrections to the model, and it is recursively sending back the correction information and its old response for the model to correct it again, right? So it checks, it suggests corrections, it gives it back to the model. Now the model will correct it, send a new response, it will check it again, it will again send correction, and this will repeat for some time, right? After certain time, this feels that the response is good and is not biased or is not inappropriate or is not sensitive, then it will return the final filtered response, right? This will go to our website backend. The website backend will give a post request. The post request would be sent as the final response on the website front end to the user. Okay, this was the simple explanation. Coming to the technical pipeline, detailed technical pipeline explanation, right? It is quite similar to this part, but it is I have explained, I have shown it in a bit detailed manner over here, right? So the input is coming. We have the prompt refiner, which is the fine-tuned Llama 3.1 70 billion model. It returns a refined prompt which goes to the planner, which I said earlier, for which we have used a reasoning LLM, which is O1 mini, right? This planner returns a plan, or which is a approach to solve the case, right? Or to generate a query for user's problem, right? This output now goes to uh, a search query generator, right? Which is another fine-tuned Llama 3.1 model, right? It generates some search queries. Now the thing is that at a particular go, a model may not generate all the possible search queries which is required to get all the possible information relating to a problem, right? So we need to repeat that process. So what happens is that we use the high temperature. High temperature is basically where model shows high variability, right? So we use the high temperature setting to use high variability. We generate many search queries so that all search queries are varied, and we create a search query stack, right? We repeat this process recursively and generate many queries, and we create something called as query stack. Now this query stack will contain lots and lots of queries. We pass it on to another model which is uh, just has the role of looking at all the queries and giving me, suppose it looks at 500 queries and it returns me 50 queries which are good for the for us to search on Google and get some information, right? So it will take some, for example, 500 queries and return me non-redundant and robust 50 queries which will return me all the information required for the problem, right? So we will get a refined query stack, right, of way lesser number of queries. Now we will search on this automatically. Everything is happening over here automatically. So these 50 queries get searched on Google, right? Google returns website links, right? These website links are scraped asynchronously, which means that they are scraped together, right? They are not scraped one by one. This is to save time, right? Now we get a search content corpus. This search content corpus contains all the information that we have searched for, right? So we got all the information, but the thing is that many websites, many articles, many these things, they contain same redundant information, right? So we need to summarize everything into a particular structured output what we have gotten from our Google search, right? So we pass this search content corpus to a summarizing model which is Llama 3.1 405B. Since this is a huge amount of text, we pass it to a larger model, right? And we get a summarized search information, right? So this part of the searching part of the our pipeline is over. Coming to the database retrieval part of the pipeline, right? So we had the plan. Coming back from the plan, we got two deviations. One was the search side and one was the database retrieval side. Going to the database retrieval side, the plan goes to a relating information snippet generator. Now how do we firstly retrieve information from the legal database? We use a technique called as RAG. But what happens in RAG is that the input user prompt or the input plan may not match with the data, right? Basically we are doing data matching over here, right? Which matches with the data, or which matches with the sentiment of the data, or which matches with the idea of the data. But the thing is that what the given plan is may not match with the what is the data existing, right? So what we do is that given a particular plan, we try to generate lots and lots of snippets. Ki what type of data we may be having in the legal information database relating to that particular plan. So we again put high variability or high temperature on the model, and we recursively generate lots and lots of information snippets, small information snippets of small number of lines, 2-3 lines. We generate it recursively so that we get lots and lots of varied lines and varied thoughts of data, right? These thoughts are, some of these thoughts must be well represented in the legal information database, right? So we have the related information, right, which is generated from the potentially relating information snippet generator. This process is recursively repeated, and we finally get related information corpus, right? This would be used for our retrieval augmented generation, which is RAG, right? So these are divided into chunks, and these are matched with the legal information database using RAG. Now RAG is a complicated process. Due to shortage of time, I'll not explain it in full, but it basically matches the data according to a vector embedding space, which is basically matching it according to the sentiment, or matching it according to the what is the meaning of the data, right? So for example, the words may not be same, but if the meaning of two parts of data is same, then they will get matched by RAG, right? So we are using RAG based matching. We are also using word based matching, right? So we combine RAG and word based matching. So we use something called as hybrid RAG, which is a combination of both, right? And we are not only using hybrid RAG, there is a new technique which is known as contextual hybrid RAG. So we are using that, where we combine hybrid RAG along with a particular context which is given to each chunk of the RAG, so that it can well represent the thought that we are looking for, right? So we are using contextual hybrid RAG. This will include everything from knowledge graphs, cosine similarity, right, HDB scan clustering, artificial neural network matching, and it will also include word-based search, which I said is basically matching the words which are present in the database to what is present over here with us, right? It is also using positional based encoding. Now positional based encoding is is a huge necessity for us, because later it will help us to prevent hallucinations. How? I'll tell you that later, right? But all of this, when combined, we get a tool which we call as Facebook AI similarity search, right? FISE. We are using that to implement contextual hybrid RAG more effectively, right? And we are also using recursive large chunks retrieval by large context LLM. So this is basically dividing the legal information database into large chunks, and it is passing it recursively to a large context window LLM, and it is retrieving it from there, right? So we are not only using the traditional non-LLM based method for retrieval, we are also using an LLM based retrieval method to account for disparities in both. LLM based method have some disparities in their own, and non-LLM based methods have some disparities in their own. So combining both their outputs will give us a better total general output than using only one of them, right? So we combine the output from this method, from the contextual hybrid RAG method, and from what we got after searching online. This whole is combined into context information for the LLM, and this part is combined with the input which we are given from the user, with the refined prompt, and with the plan which was generated from our reasoning LLM. Creates a whole corpus that we give it to the LLM, right, to basically uh, help it to solve the case, or to answer our problem more effectively, right? Because the information is such large, we again use context caching for faster generation, for faster inferencing, and for better performance, right? And we use another reasoning based answering agent, which is Open Preview, because it is great at thinking about the data analysis, and then understanding its legal aspects of why something should be done or something should not be done, right? After thinking through all the data and all the search queries and all the retrieved data, it finally returns a response which will be passed to the red teaming pipeline, and again it will recursively filter it and suggest corrections, and when it feels that the response is okay, it will return the final response, right, which will be shown to the user as the response on our website, right? Moving on to what we have now, we have also implemented a very basic version of this, right? So this is the very basic pipeline version of this which we have implemented. I'll explain this to you later, first let us take a look at our website. Yeah. So taking a look at the website that we have created, this is a very basic version of the initial model that I had shown to you, right? So we have created this on Flask, right? Flask is a Python based web backend, right? And we have used normal vanilla JavaScript for the front end, right? I'll just run the application, right? So you will be able to see it over here, right? And I'll just put in the response, right? Just a second. So I've opened the console over here, right? So that you can see that what is happening in uh, what is going on when I click enter, and let me just paste this, right? So I have pasted that I am operating a business in Jammu and Kashmir. Which rules will apply to me and what do I need to be aware of? This is a very simple question. We are just using this question to demonstrate the website that it is working, right? And this is just to save some time that we are not going into a very detailed question, right? So I click enter over here. It says that button is clicked, sending request, and this is the question that we had put in. Now you can see that in our backend, the our agent Veritas starts to generate a response, right? Our response is like this. So firstly it plans, right? What I said, it will plan. Now it will also think about the plan because we are using a reasoning based agent. So it is thinking about the plan. It is pausing, right? Because we have introduced this another concept that because LLMs do everything together, they are not very efficient. So it is pausing for a while, then it is reflecting on its thought, right? It is reflecting that whether what it thought was correct, because often LLMs are very confident about what they think. So to counter that, we have introduced the reflection inside the LLM, which is basically allowing it to think about its earlier part which it had written, right? So its earlier plan and it's what it had thought earlier. So it is pausing, then it is reflecting on that, then it is analyzing what what it has responded till now, then it is again then it is generating the final answer, right? So the final answer, our question was, I am operating a business in Jammu and Kashmir. Which rules will apply to me and what do I need to be aware of? The user will only be shown the final answer and a confidence value. The confidence value is nothing but the confidence with like how confident the LLM is of the answer it has generated, and nothing else, right? So it has returned us the confidence value that it is out of 5, it is which confidence level is 4. So it is quite confident about its answer, and it has generated the answer: business operation in Jammu and Kashmir, blah blah blah, the taxation laws, the labor laws, right? It has given us acts, right? So for example, business operate employees provident funds and miscellaneous prevention act 1952. Then this Environment Protection Act 1986, the Water Prevention and Control of Pollution Act 1974, and so on. Right. So we have implemented a very basic version of the initial model that we had shown. It first generates the answer in backend and then it returns it to the front end. Right. Now I'll go on to the Google Colab that we had created, which contains the model, and I'll show you in detail what is happening, right? Because in website you won't be able to understand what is happening in detail, and you will only get an upper overview of what is happening. We have implemented it in very detailed manner inside the Google Colab notebook, right? So I'll be just be going on and done. Yeah. So I am here on the Google Colab notebook. I'll just be showing you that what we have implemented as the pipeline, right? Yeah. So these here we are just importing the website, the modules we require for our code, the libraries. This is the code that we have written for scraping, for searching the website using Google search engine, right? So we are getting the particular query that we need to search for. We have the API key or the ID. It is searching and it is getting a result, and then it is returning the result, right? This is our final our agent, which is llama 400 5 billion agent, right? This is used to answer it, and this is also used to plan the plan that we had that I had shown you inside the pipeline. So this generates the plan, and this also generates the final answer based on its use case. So it is accepting its use case as a parameter, and if its use case is answer, it is generating the final answer. If its use case is plan, it is generating the plan. Right? These are just the prompts that is given to the model to generate accordingly. Right? Now we have a prompt refiner, which we said that it will refine the original user prompt. Right? We also have the website scraper. So the links that we'll get after searching on Google will be passed on to here. Right? This is an asynchronous function which you can see over here. So this will search asynchronously, and this will scrape the websites asynchronously together. So it is not happening one by one, but it is all happening together, and it is all happening at a go. Right? So this makes the process very fast, and this reduces the latency time for the user by many times. Right? So, and here we have also used a summarizer. This summarizer will summarize the final search content that we have obtained after scraping the website, right? And we all yeah, so this is another version of the summarizer that I have implemented, right? And this is just the our function which we have I have written to get the response from the model, right? So initially I've set responses as null, right? This is our input prompt. Again, the same input prompt that I am operating a business in Jammu and Kashmir. Which rules will apply to me, and what do I need to be aware of, right? I had run this earlier, so this was the response when I had run this earlier, but I'll run this again in front of you and show it to you, right? I've run this. So it is refining the input prompt, and the refined prompt it has generated as a business operator in the union territory. This. Okay. So now I'm writing a plan prompt, right? Plan prompt is basically contains the original prompt and the refined prompt. I'll just print it to show it to you. Yeah, so it contains the original prompt and it contains the refined prompt. Now I've set the planning string to be null. I'm passing the plan prompt to the planning agent, and the planning agent will return us an output, right? So yeah, so it is returning us the output. As you can see, it is slowly generating it. So it has generated plan to solve the query. Step 1, research the laws and regulations in Jammu and Kashmir, etc., etc. Step 2, understanding the impact of Article 370 and 35A. We had not given this it had made out of its own, right? So it is automatically understanding that, okay, Jammu and Kashmir means Article 370 and 35A. It could be applicability of central laws, it could be applicability of states and state specific laws and regulations, etc., etc. So it is creating a comprehensive plan which could be used by other which could be used as context by other agents inside our pipeline, inside our multi-agent framework, right? So it will take some time because it is a heavy model, so it takes a little bit of time, and our API provider is a bit slow, so it is taking some time, but it has generated. Now I am generating a search prompt. This search prompt consists of the initial prompt, the refined prompt, and the plan, and will be used to generate search queries based on that, right? So this is our search prompt. I've just printed over here, and now based on this plan, our search queries will be generated, right? I've shown that how it is generated in the pipeline, right, which I had earlier shown. So I'm just running this. So now you'll see that there are search queries which is being generated. Yeah, so these are the search queries which are generated. These will be searched on Google, right? So here just the queries are being extracted. You are seeing that this is being written in an XML format, and it is extracted as strings, right? As list of strings, right? Now it is extracting the URLs, and it is searching Google for these particular search queries, right? So you will see that URLs would be extracted here. The Google search is going on. Yeah, the Google search has ended. Now I am just running, and see, you can see that depend on these search queries, multiple URLs have been extracted, right? So these are the search particular URLs that we have extracted. Now we will scrape each of these URLs. We are also getting a description, but we don't need that. We need a detailed content of the URL. So we will scrape all the URL, right? And this portion contains the URL summarizer part as well. So first it will scrape, then it will summarize the URL, and accordingly we will get our response, our information, search information, right? So it is currently scraping the information. It will take out 10 to 15 seconds to scrape it, right? Because it is scraping about 100 websites together, so it takes a bit of time. Timed out means that 4 websites failed to respond, and rest 97 of the website had responded, right? Now it got the information from 97 websites. Now it is summarizing that information, right? So it takes a little bit of time to summarize, but it won't take a lot of time. It should summarize in just a few seconds, right? So like in a minute or in a minute and a half, the whole process should be done, right? Yeah. So it has given the first level of the summary. Now it has gone again and it will generate a second level of the summary. So this should also take like 15 to 20 seconds more. Yeah. So all the search information is now summarized. After that, this is just printing all the search information, right? So this is for the Jammu Kashmir Reorganization Act. This is for central laws applicable. So here is a summarized version of after the abrogation of Article 370, a total of 106 central laws became applicable, etc., etc. So it has summarized all the search queries. Now I'll just quickly go on to the prompt, right? So this is our prompt, which consists of the initial prompt, the refined prompt, the plan, and the search information, right? So I'll just print the prompt for a reference, right? So it consists of the initial prompt, the refined prompt, the plan, that retrieved information, which was nothing because we haven't implemented the retrieval part in this notebook, but we have implemented the search part. So this was the search information, right? Now you will get the final response from our agent, right? So I'll just run this, and it will, yeah. So this was the our initial part. Now our agent, which is Veritas, has started responding over here, right? So uh, it is for generating an updated plan, like we had stated that it will generate an updated plan. After generating an updated plan, it will start responding based on that, right? So it will start thinking on the updated plan, then it will pause for a while, then it will reflect on its thoughts, then it will analyze it, then it will think again, and it will repeat this process unless it has an answer. After it has an answer, it will generate the final answer, which we'll get in final answer tags. And after we have got the final answer, it will also generate the confidence value which it has over its answer in confidence tags, right? So it is thinking and reflecting over here, as you can see, right? So it is analyzing whether it has thought correctly or whether it has made some mistakes, right? So here you can see that based on the reflection, it is saying something. Upon further reflection, it appears that there is a comprehensive overview, etc. Now it has generated the final answer, right, over here, and it has generated a confidence value. Now the whole thing will not be shown to the user. Only the final answer and the confidence value will be shown to the user, for the user to better understand how confident the model is, and just for the user to get the final answer part only, right? So so this is the confidence value. The user will only see this confidence value, which is 4 out of 5, and answer, which is the laws and regulations governing this, etc. So it has come up with the laws, 1966 Jammu Kashmir and Shops and Establishment Act. Then it has written to comply with the tax laws, including GST and income tax, etc. Right. So this was the basic version of the pipeline that we had implemented in Google Colab. We had also also shown you the website, and we had also shown you the comprehensive overview of the pipelines and the technical approach and the idea from the presentation. Thanks a lot.